بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد. Ramadan Mubarak. May Allah accept our good deeds and praise. In this session, we will cover the chapter 16. We already covered the chapter in the previous lecture, in the previous week. And I believe there were some points that we need to emphasize on them. We need to make them clear. So what we are going to do now, we will have two recordings for the previous week. So the first recording is going to be this one. I prepared a small presentation that will give us some of the concepts that we need. And as well, I'll cover the first 10 slides again. And we will have the second recording. So the recordings will be divided into two. You will have two links. The second one will be the same one that we had previous week, and it will cover the last 20 slides. So without further ado, let's get started. We will have a basic introduction about the concepts that we need to understand before we walk through chapter 16. First of all, we have to understand the meaning of storage or disk. Secondly, we can have a look at blocks and pages, and then we talk about files, lastly records, and then we will have an example to make the picture clear. This definition will be with us through all slides, so we have to understand it very well in order to understand the concepts of the storage, blocks, files, and records. So relative data information is stored collectively in a file format. A file is a sequence of records stored. A disk drive is formatted into several blocks that can be stored or store records. And lastly, file records are mapped onto those disk blocks. It might not be that quite clear now, but I promise at the end of this presentation, it will be quite clear. So first of all, we know what's in front of us. This is a relation. This is a table. And it consists of 4 or 5 columns and also 5 records. Okay, each employee has a name, a first name, a last name, a city, age, and salary. Each one of them considered to be a record, and we already know that before. So this is the first part of our definition. Now you can see it highlighted. So it's a relative data and information is stored collectively. So they are in one place because all of them are entities or all of them are employees. And we already know that from all the previous lectures and labs we had in this course. A file is a sequence of records stored. So this means a relation table, for example, an employee table, can be also called a file. Now let's jump to another concept, which is disk and blocks. So what's in front of us, it's the storage, or it can be a disk, right? A disk consists of blocks. And a disk is divided into equal sized blocks, or pages, sometimes we call them, is set by operating system during disk formatting. So it's not dynamic. Block is going to be fixed until you reformat the disk. So they already have a specific sizes. Each block has a specific size already assigned to it. It's not going to be changed. So for example, or before we jump to the example, block size is fixed during initialization and cannot be changed dynamically. It's already assigned by the operating system and they will be there forever, unless you reformat the disk and then you change. So typical disk block sizes range from 512 bytes to 8,192 bytes. This is the typical. So now we already know what is a record, what is a table, what is a file, and we know blocks and storage. Okay, so in this case, we can also define the second part of the definition that we have at the bottom. So a disk drive is formatted into several blocks. that can store records, okay? Then if we want to have an example, let's say that we have this file or we have this table, which consists of 5 records and 5 columns. Each of the record has a size, right? In order to be saved in the disk. So in order to save these records in the disk, we have to make sure that their sizes is enough to be saved in that disk. So this file consists of 5 records, and we can see here just an example of their sizes. So the first one, for example, is 200 bytes. The second one, it's 100 bytes, and etc. So in order to save that file into disk, we have to make sure that these records are saved into the disk blocks, right? And this is the disk, and here we have the blocks. If we just assume that the block size is 512, okay? So each of these blocks has a size 512 bytes. Just can hold 512 bytes in each one of them, okay? And we want to set the former file, employee, which I showed to you. We want to save that file into the storage or into the disk. How can we do that? So we have to count first how many bytes do we have. How many bytes in total? If we just count them quickly, there will be 670 bytes. And we know for sure that each block can just hold 512 bytes. So it's just a straightforward division operation, 670 bytes divided by 512 bytes. That will give you how many blocks you need in order to save that file, okay? So if you divide it, you will get something around 1.308, and then you will have the ceiling function. So you will get the ceiling. After you get the ceiling, that will be 2, which means 2 blocks in order to save the information in one file. So in order to save this file, I need to reserve 2 blocks from the disk. So now I believe we can read the definition without any struggling. Relative data and information is stored collectively in a file format. We saw that, so all of them were employee and stored in one file. A file is a sequence of records stored, right? A disk drive is formatted into several blocks that can store records, and we saw that in the block and the disk figure. And lastly, file records are mapped, and we saw how we map them. So we do have the file, and we mapped the records inside the file into blocks, okay? So this is the last part of the definition. File records are mapped into those disk blocks. File organization, which we will cover now in a minute, which is the main chapter for the week number 10. File organization defines how file records are mapped into disk blocks. So we will see how we will arrange those records inside the file in order to save or in order to map them with the blocks. File organization, we will say 3 types of them: unordered or heap files, ordered or sequential files, and lastly, hash files. So let's check them one by one. And I'll upload this introduction presentation for you as well to just have these concepts clear for you all. Again, I'll explain again the first 10 slides, and I will leave the remaining that will be explained in the second link for you on Blackboard. So you can carry on with the second link to understand the rest. So in this session, I'll talk about unordered or heap files again. I'll talk again about ordered or sequential files, and lastly, I'll talk about hash files. So now we already know the differences between file and blocks and disk as well as records. File organization, how the physical records in a file are arranged on the disk. Okay, so this is file organization, how we will arrange the records inside the file to be stored into the disk. Access method, how the data can be retrieved based on the file organization. So this is quite important, and we already discussed why it's important, because most of the time after you insert a record, you will be looking for it. You just want to modify it or delete it, or at least retrieve the information from there just for a specific purpose that you need. We study 3 types of file organization. So all what we are going to do, it's going to be about how to arrange these records inside a file, and that will be reflected into the disk. Okay, so unordered or heap files, ordered or sequential files, and hash files. We examine each of them in terms of the operations we perform on the database. So insert a new record or search for a record. We will start with unordered files. We have done that before with you in the previous lecture, so also called the heap files. They will be just one after the other. This is because, or this is why it's named heap or pile. So whenever we insert a new record, that will be just added. There will be no order or a sequence. You just add them, first comes, first serves. And records are placed in the same order in which they are inserted. And this is what I just mentioned. Insert operation is fast because no need for ordering. You just, whenever you have a new record, you just add it to the file. Let me just grab Word document, for example, to just draw for you some order we need. Draw, and then choose red, for example. So I'm having the file here. This is the file. Let's say it's employee file. Okay, and we have the records. So this is the employee number 1. For example, this is going to be the SSN, let's say. And we have, for example, name and other columns, right? So the first employee comes with the SSN2, for example, and it will be added whenever the other one comes again, or we insert a new employee, that will be added to the last of the employee file. So for example, then 1, it will be added. There will be no order, they just will be added. So the insertion is going to be quite quick. Search or update operation, slow. Why it's slow? Because if you have, for example, let's change a bit the values. So this is, let's say, 300. And then you put 1. And then you put, for example, 20, 5. See, these records are saved just in chaos. They are not arranged at all. They are not in order as well. So in order to find one of them, you need to pass through them one by one. And this is going to take quite much time. And this is why it's slow, because it's linear. So with linear search, I believe you already took that maybe in C++ before, on data structure now. So linear, you will just pass through them one by one till you find them. The purpose of having, let's say, quick finding is to not access a lot of blocks. Okay, this is the purpose that we want to look for. The purpose that we're looking for, we want to minimize the accessing of blocks. Okay, so for example, these 3 records might be saved in one block. Okay, and let me add also 4 records. This is 4, for example, and 352 or 35, let's say, and 7. These are going to be saved in another block. This is just an example. It depends about the size of each tuple or each record. So if these are going to be saved in one block, I need to pass, for example, I'm looking for the record 35, which is the one here. What I would do, I'll pass through, first of all, 301, 20. They will be saved where? In block number, for example, 1. So I'll go to block number 1, looking for 35. I won't find it. I'll go, for example, this one might be saved in block number 3. So I'll jump to block number 3 and then search for it. So actually what will be happening behind the scene, blocks will be taken from the storage to the memory in order to look for the record or for the tuple, and that consumes time. So every time you jump from block to block, that will consume time. So again, you're looking for the record 35. You didn't find it in block number 1. You didn't find it either in block number 3. So you look for block number 2. And whenever you find block number 2, you will just grab it and search for 35, and then you will find it. So see how that's going to take time. Ordered files, on the other hand, they choose a field. And when I say a field, it means an attribute or a column, basically. So also called sequential file. Why it's sequential? Because it's ordered, and usually it's ordered by ordering field. And when the ordering field, by the way, can be any columns. It shouldn't, or it's fine to be any columns, even though it is not a primary key. Okay, it could be a candidate key. But if it is a key, if it is a unique, okay, that's going to be called key field. If it is not unique, any just record, for example, address, that's going to just be named as ordering field. So you might arrange them with the address, for example. It will be fine, but it will be called ordering key or ordering field, not key field. If you order them with something unique like the SSN, they will be called key field, okay? And this is going to be the best practice. So if the ordering field is also a key field of the file, or sorry, of the file, a field guaranteed to have the unique. So I'm having a file, and if it is a unique, so that's guaranteed to have a unique value, it's called a key field. In each record, then the field is called the ordering key for the file. A binary search that will be applied because they are in ordered, right? And can be used to search for record on its ordering field value. And this is how it can be done, by having them in order, and this will be done by binary search. We already have the algorithm. So if I show you the algorithm, I have it already, and I showed it to you last week, I believe. You can find it in the book. Just give me a second, I'll be back. So we have the binary search, and you already took that before in data structure, I believe, or map, or maybe C++. With binary search in here, what we're looking for, what we're going to divide is, we are going to look for blocks, okay? So if they are ordered, let's have this example first of all. Or let's finish this slide and then jump to the example and then see the algorithm. So binary search can be used to search for record on its ordering field value. And this requires reading and searching log with the base 2 of the file blocks. On the average, an improvement over linear search. And we will see the improvement in the coming slide. Reading the records in order of the ordering field is quite efficient. We will see why. So this is an example. You can see it. Let me just show you the full screen. Here we have a file. It's an employee file, let's assume. Okay, it's written down there. It's a file of employee. And we have a record. You can see it. And because the file is quite big, so it's saved in many blocks. So we can see here, first part of it is saved in block number 1, 2, 3, 4, 5, till last block that we have for, or that reserved for this file. Now our goal to reach to the record of that block. So first of all, we need to reach to that block in order to reach to the record, right? And we need to minimize the number of accessing blocks. We don't want to access to 10 blocks or 20 blocks or all of them. And we can just look for the block that is specific, okay? So in this case, I'll repeat. In this example here, we can see a full database. Let me just show you the full screen. Here's an example of employee database. So we can see it, and it consists of a lot of records. And because of that, we can see different blocks assigned to this file.